Ngale.
Mark, wait, Amanda kuphone.
Good morning. Hello? Hello?
Hapa nimeona kama amezileta. Hapa naona kama amezileta. Kila mtu ni nyamazi.
Good morning.
Morning, sir.
Yes,
Good
how are
morning,
you?
sir.
Yeah, okay.
Yeah, we want to start. Please get ready. We want to start. Are you seeing my screen?
Yes, sir.
Okay, may all of you mute now. All students to mute. Welcome to the lecture of the course. We did see an overview of the course. We gave the course outline. I did send word, and the Odell office sent communication that you need to register fresh for you to access the course materials, that you need to use the KUC1250 January 2024. That's what you're supposed to use. So I saw a number of you had commented that you could access. That's fine. So most of you, those of you who have not registered, please register for the course and access the course material. We looked at this course overview, and we saw that part one was looking at statistical concepts. And we defined statistics as to be methods of collecting, organizing, analyzing, presenting, and interpreting data. We define data to be information. And why do we all do this? We do this because we want to make decisions regarding various phenomena. If you look at categories of data, we define primary data, secondary data, quantitative data, and then qualitative data. We say the quantitative is either discrete or continuous. We looked at methods of data collection, where we can use questionnaires, interview schedules, observations, and currently we can use technology, photographs, and videos. We did define the various forms of the populations. We looked at target population, accessible population, the sample population, and then the units. And this population is where we get the information. This is where we get the data. And the data that we collect from the subjects, from the population, is what we refer to as the raw data. So this is the data that we record as it occurs from the various units. Then we said that's collection. How do we tabulate? We tabulate in form of presenting the raw data in terms of tables. We did consider the reasons for organizing or tabulating data, and we say this for purposes of comparison, for avoidance of unnecessary details, to summarize data, and what have you. So we considered this and we looked at it and said that how do we organize data? Because tabulation is part of organization, and we said the simplest way is to arrange the data in what we call an array. An array is an arrangement of information or data in either ascending or descending order. Ascending means we start with the least to the greatest. Descending is the reverse. We start with the greatest to the least. We saw how we could tabulate some data in terms of two examples. One, regarding the employees in a farm, and two, we did see how we can organize the information regarding the student performance that we saw in example. So you did look at this, you did compute, you did respond very well in your chat box. So if you did it well, this is what you are to come up with as the table. So what do we look for as we present this information? We look at the key parameters that are given. If we consider that student performance, what are we given? The key parameters we have is regarding one, the age. We have those that are below 20 years and we have those that are above 20 years. So age is what's presented to people. Then we are given in terms of men and women candidatures. Then this is to be categorized in terms of those who passed and those who failed. So that is what gives us now the performance. So these three key things, the age, the gender, and the rate of passing or failing, this is what we are supposed to actually present in our table to bring it out. So we summarize all that we were given into a tabular form. Out of this, we are able to avoid unnecessary details. We are able to make comparisons. We are able to summarize the information and are also able to, as we did see, as the reasons for tabulation, to locate the required data so easily. Today, we wish to look at what we call a frequency distribution table. We want now to graduate from just an ordinary table to what we call the frequency distribution table. So what is a frequency distribution table? This is just a table that shows how the total frequency is distributed over the various values of a variable. A variable is something that is or has a characteristic of interest. We look at a variable like employees in a farm, the way we considered in our example one. We look at a variable like performance as considered in example two. So there are very many performance. We can look at age per se. We can look at marks. We can look at sets. We can look at maybe the number of vehicles passing through a police roadblock. All these are variables. So the parameters, the key that come out of the variable, this is what we focus on so that we can that in terms of table. So with the table that we defined as a frequency table, we want to look at how is the totality, say the students, you are about 2,000. How are the 2,000 students distributed over the various values that are there in terms of maybe student performance? So how do we do this? We do this by grouping values of a variable into class intervals. So if we get this and we are looking at marks, then the number of times a given mark occurs. reflecting the number of students who got that mark. Then the table that we generate, then that table is what we shall refer to as a frequency distribution table. So as we do this, ladies and gentlemen, we are focusing on generating a table that will give us the variable and then the occurrences of the various values of that variable. We may look at this in terms of the example that we had looked at earlier. Look at the example that we had in terms of the exercise. Look at this example. If I may highlight this. What we are looking at in terms of exercise question 1, that the data below was obtained from the heights in centimeters of students. Then we have 168, 142, 171, 153, and so on, up to the last one. So how do we now create a frequency distribution out of this? We know that the variable we have been given here is in terms of the height. We know that the variable height is given in terms of centimeters. So we can generate a table that shows the various values of the variable height and the number of occurrences, how many times that height or the number of students with that height is. So if we look at example, exercise 1, the easiest way is to have this is an array. So can we now arrange this data in an array? Let us arrange the data of exercise 1 in an array. Please do that and share on the chat box. We want to use the ascending order. So start with the list. You have 168, 142, 171, and so on. Arrange these things in order from the least to the highest and share on your chat box. I have 2 minutes to do that. Please, you have 2 minutes.
$159, $161. Two, 61, 173.
Share your results on the chat box. And please, there is a lot of echo. So could we minimize the echo? Wind up, wind up, wind up. Now, for us to move faster, consider what is given on your screen. You can do this together. Suppose you have to put a variable. One or two, 1 or 5, 1 or 8, 1, 0, 4. Let us give this value a variable. It can be anything. So we have our variable, which is given, and we can arrange this in ascending order. So ascending will start with the list. So looking at this, the list is 86. One 108, 201, and finally 204. Then that's what we are referring to as an array. This is the simplest way of but we want to see how many of these variables our variable, because we want a table, our variable, then the number of times.
Mr. Tukupati.
Atukupati.
So for this, you have
Tukupati.
Can't say anything, sir.
Mtu wa kamera aone shida ya kamera. Atumuski, atuoni.
Ngeni macho.
Wewe shauri yenu, nyinyi endelee kulia hapa msikia muone na sisi.
Sasa ni mambo gani?
Can see.
Each and every variable considered as an element. Suppose maybe I had another variable, say 1 or 8. If I have 6, 1, 5, 1, 8. I have another 1, 0, 8. These are added there, 1 to 8. This one. So you realize that I have two values. The value of 1 of 8, and therefore the number of times that you occurs will therefore change to this is the number of times that given value occurs, and therefore In that case, you can have this as
We can't hear you.
because I count 1, 2, 3, 4, 5, 6, 7.
Wewe kusikia si shida, elewa.
Number of values that I have.
Wallahi mimi sielewi. Nasikia lakini sielewi.
Generated is also
Hello.
this is one part.
The host, can you mute this guy?
This is what so if you look at the answer, what I asked you to do, then you can also get the thing like that. This is what we are referring to as a frequency.
Tulikuwa tunapenda tu
Nani hesabu tupo.
Instead of generate a frequency table also, yes, we can. We can generate a table, but that table now we call it a group frequency table. So frequency tables are either grouped or small values, where each value of the variable is considered independent. But if the data is large, then we generate what we refer to as a group frequency table. With a group frequency table, now we come up with groups. That's why it's called group. We come up with groups where we generate what we refer to as the intervals. That we can group together a given range, within a given range of variables. How many fall in that? Say, for instance, for this, I can have 95 to 100 if there were two values for this variable. Then I can have 101 to 1, say 4. You see, I'm not generating groups. These groups are what we refer as intervals. But before we get into that, let us see what is the procedure of generating groups for large data. So how do we generate groups? We have the following procedure that we use. We go, Here again. So for us to have that grouped frequency table, or what we are referring to as a grouped frequency table, so we can group these variables into intervals, and we count the frequency that is occurring into each interval. And this applies for large data. So if we do this, then we generate what we call a grouped or continuous frequency table. To generate this, we need to follow the following procedure. We determine the number of, or the range. What is the range? The range is the difference between the largest and the least observation. We can denote this by letter R. Then we denote the number of classes. The number of classes usually is between 5 and 20, depending on the amount of data that we are handling. Then we determine the classes, the class size. So how do we determine the class size? This day should not be there. Determine the class size. These are quotient of R over K. Then we determine the lower class limit of boundary. I'll explain what the limits and boundaries are, so that it includes the list observation and the others are generated thereof. Then we tally the observations. So the procedure is simple. We find the range, decide on the number of classes, determine the class size, then determine the lower class boundary or limit. Then we tally the observations. How can we do this? Look at the following example. Look at this example. Suppose we are dealing with marks, and the marks were as given. Please copy those marks because we want to use them. Copy those marks. Copy those marks. Pressed on this one, it should just bring it automatically. Yes. I thought if I pressed on this, it takes me to the keyboard. Just click on it. No, I try for myself. Okay. So if you look at that example, we are getting marks. Then we can follow the procedure. We say number one is to determine what we have as the range R. The range R is the difference between the highest and the least. So if you look at that, the highest was, if you check well, is 74, minus the least, 25. And if you do this gives you 49. Then we determine that we select the number of classes. This is K. Suppose we want to say 5. Let's use the list 5. So we need to determine the class size. In some books, they use I. In other books, they use letter C. So I is only a quotient of R over K. Our R is the range, which is 49. Divided by our K is the number of classes, which is 5. So if you do this, you will get 9 points. That's 45. The remainder is 4, it's 9.8. Can we approximate this to 10 so that we work with the whole number? We approximate this to 10 so that we use a class height of 10. The range is 49, and the classes we want them to have 5. So how do we now use this to generate the limits and the boundaries? So the value we are looking at is marks. Then we have to get the number of students who scored that mark. This is what will give us our frequency. As to extend from 25, 10 units. So we count from 25, 10 units. Many of you will do an error. 25 plus 10. No. I remember in my early days, we were not how to count. So we count 10 units. 25, 26, 27, 28, 29. 30, 31, 32, 33, 34. So 10 units will give me 34. So it's from 25 to 34. Then we have said that the other class intervals are generated by adding the class. So from the first one, I have 10. So I can now add on 10, 10, 10, 10. So from 25, I'm going to 35 to 44. If you count it, then this is 10 units. From 35 to 44, I add 10 and get 45 to 54. So I do this until I take care of the largest or the highest information. So I'll have to extend this from 55 to 64. From 65 to 74. Now I have my 25 and I have 74. Then we now have to count how many students got a mark of between 25 to 34. Count and complete the table in terms of the frequency. Count and complete the table in terms of the frequency. Then share with us in the chat. I repeat, from the data given, we determine the range R. The difference between the highest and the 75 minus 25, we have 9. We select the number of classes K, select R, the minimum. Determine the class size, R over K, giving us 9.8. We round this to 10. So we want a class size of 10. So in step 4, how do we ensure that we include the risk observation? We can start with the 25 with the mark. Then count 10 units. This will give us 34, not 35. We have added that for the subsequent intervals, we now add the class size. So 25 plus 35, 25 plus 10, 5. 34 plus 10, 4. We do that until we take care of the higher information. This will generate the intervals for the variable marks. Then I've asked that count to see how many students fall in this interval 25, 35, 34, 35, 44, 45, 44, and so on up to the last one. Have a minute, do that. Almost all. Rebecca. Please complete the chat box. Complete the chat box we see. For all the intervals, Emmanuel, you have given 2 for the first interval. Yes, correct. We want to get others. Peter, you have 216,886. I don't know. Let's see what others give. $35 to $44.17. Deborah, check. Ronald Mulongo, 216,886. Check the last interval. Check the last. 65.74. Collins, check the last. Seemingly you are getting the last the different answer. Colin Otuya. Check Emmanuel, check the last one. You are giving us 2. Check others are getting 6. The last is 4. I don't know. No, class boundary or limit. Such that it includes the list observation. The list observation here is 5. So we pick the first one so that it must include the list observation. Then we proceed adding the class size within the interval so that we take care of and including the highest observation. If we do this, then what is the rest is what we are trying to continuous or frequency distribution. This is what we are doing. But what is now this that we are trying to boundary or the limit? I want us to please be careful. And we can draw this even from home. At home, we talk about the boundaries. We share plots, fences. We talk about the boundaries. That if this is our place for person A, this is our boundary, and this for person B. That for plot A, somebody can extend plowing up and including the maximum. You will get as close to the boundary. This is what we are valuing as boundary. But when plowing or constructing, you don't do it from the boundary. You go as close to. Even B, you start as close to. So the process you can have, that's what we are valuing. The process you can have. The farthest, the very farthest you can go, you have to back at the boundary. What are we saying? Come back. That is what we have been given. That the values, the values of 25 and 34. The values of 25 and the values of 34 are the farthest the what we can go. And these are what are forming the limits. These are the limits. And to be specific, the ones on the left are called the lower class limits. The ones to the right are what are referred to as the upper class limits. But what is the farthest extent you can go? If you look at the first interval, 25 to 34, then this one starts at 35. We can borrow this argument from the number line. Recall the concept of the number line. How does it work? That I have this as my number line. I have here 34. I have here 35. This being the limits. But the farthest I can go for the first one is up to here. That's where the boundary is. So where is this boundary between 34 and 35? It should be the average of these two. So the farthest I can go is 34.5. That plot A can extend from 34 to a farthest of 34.5. B can start the farthest from 34.5 and so on up to the next. So this average of the limits is what is giving us the boundary. And therefore, the interval 35 to 44 would extend from 34.5 to 44.5. Meaning the first one will extend up to 34.5 and this one 24.5. It continues that way. The third interval will start from 44.5 to 54.5 using the same argument. This will start from 54.5 to 64.5. Then this from 64.5 to 74.5. These values, these are what we are referring to as boundaries. These are boundaries. The ones to the left are forming the lower class boundaries. Please get this because we are going to use them. The ones on the left, 24.5, 34.5, 44.5, 54.5, 54.5. These are forming the lower class boundary. The values on the right, 34.5, 44.5, they repeat but now for different intervals. These are referred to as the upper class boundaries. So this differentiates between the limits and then the boundaries. With the analogy from if this is plot A, this is plot B. Plot A can extend up to 34. Plot B starts from 35. But in between there is a boundary where they share. The farthest one can go. That farthest that you can go. The common value, whatever is common between the two, is what gives us the boundary. So like for the first, they are sharing at 34.5 because from 34 to 35. Consequently, therefore, we are only averaging these values. If you average these values, then you are getting where the boundaries is between those various class intervals. So that differentiates between the lower class boundary, the upper class boundary, the lower class limit, and the upper class limit. Look at example 2. Try this example 2. So what you are saying there is right. Who is this? Let us comment. So, Doc, you mean the upper class boundary of a constituent class is the lower class boundary of the preceding class? Exactly, that's correct. That's what we mean. You are a good student. I'm happy you are now following. So let us get back to our our lesson. So that was example 1. So if you worked out that, that's what we have worked out. And if you did correctly, this is what you will get: 2, 15, 8, 8, 6. So let us proceed to example 2. Suppose the age and death of people in a certain village was recorded as follows. So this is the age. We are being given the age. Let me magnify them a little. Suppose that is what we are given. Let us generate a group frequency distribution of class size 5. Generate a group frequency distribution of class size 5. So you note that at this, you have already been given the class size. So we don't need to go through the procedure. We start from where we are given the class size. So given a class size of 5, we need to identify the least observation. So if you look through this, then you realize that the least observation is I've seen 35. I've seen 34. 34 is the least observation, the one highlighted. So we need to generate an interval of class size 5 that must include this least observation. For uniformity purposes, let us start with 30 to 34, because that still gives us a class size of 5. If I start from 30, so I'll have 30, 31, 32, 33, and 34. That gives me a class size of 5. So generate the other intervals from 30 to 34. Generate the other intervals from 30 to 34. Please do that. So the least observation is 34. The highest is I've seen 65. Yeah, I've seen 65. I've seen 68. So 68 is the highest. There's nothing in 70. So from 30 to 34, 35 to 39, 40 to 44, up to and including that class that shall contain 68. Please do that. Please, the highest is 68. The least is 34. So if you start from 30 to 34 at the first interval, then proceed with a class size of 5 to include 68. Generate those class intervals. Interval is not 7. 30 to 34, 35, 39, 40, 44. Yes, continue up to and including that which consists of 68. Then tied observations. Somebody has done it well there. I can see Dixon Omoro. Ian Shisundi. Good work. Stephen Martina. Sawa. Now, generate the frequencies. Because the variable here is age. Generate the frequencies. Generate the frequencies. Just as Mapuri, good work. I want somebody who has generated the frequency. Somebody has gone up to 70, 74. This is who? I've done it wrong. Davis, Devi, 30 to 34, then 40. No. Please check your work. Davis. Check. I want somebody to present the entire table. Thank you, Dixon. Iko ndani daktari PhD napata. Nafurahi sana kama unaipata. Please include the frequencies now. One, 10. Huyu nani huyu? Check yours, it's not complete. Joseph Zachary, check, it's not complete. Joseph Zachary, check. How do you get frequency? You count the number of values occurring in each interval. Jairus Odhiambo Cheng. Count how many are in each of those intervals, 30 to 34. How many values are there? That's what will give you the frequency. Then you go to the next, 35 to 39. Count how many of those values are there. The number is what will give you the frequency. Thaddeus Wangila, fair work. I see somebody with the name of the deputy president, Rigi. I've seen it. Galaxy A010, that's fair. Just as Maburi, good work. Keep it up. Masi Nyongesa, I can see you are on track. Jaron Ruto, you are okay. Ojeng Emmanuel is okay. Angela, fine. Okay, check with this now. Four, 40 to 44, 3, 45 to 49. Have I shared the screen? I'm lost. You don't struggle. We have beyond struggling. Waandikie message hapo. Mimi nimewapoteza. I've lost that. That's long to log on. But I'm coming to logging on. We are doing fine. You end up with analysis. Analysis, you can stop that. You now go on. I'm giving you the slide up in that. Of what Japan now for practice. Sorry, I had lost internet. Sorry, I had lost internet. Are you able to see my screen? Members, are you able to see my screen? So I was saying that this is the solution. The variable we are looking at is age, and it's given in terms of the number of deaths. So we have 30 to 34, 1, 35 to 39, 4, 40 to 44, 3, 45 to 49, 9, and you can compare up to the end. The last interval is 65 to 69, and that gives us 3. So that is the table that we have for those, for that age at death. So please, if you have a question, you proceed to ask at the chat box as we proceed. So you can look at this at your own free time. Look at that exercise. Look at that exercise. Please, you can screenshot that exercise for your practice. Screenshot the exercise for your practice. So let us look at now the fourth aspect, because we looked at the statistics as being a science that deals with the methods of collecting data, organizing data, and now the third aspect is to analyze data. That we can analyze data so that we make decisions. We can analyze data so that we make decisions. And this data can be analyzed at 2 levels. So the simplest way of analysis is to determine what we refer to as measures of central tendency. What do we mean by measures of central tendencies? These are measures that describe a given set of observations. We are mainly concerned with describing the observations. That if we are looking at the age at death, we want to describe that age at the very basic level. If we are looking at performance, we want to describe at the very basic level. If we are looking at sales, if we are looking at an enterprise, we want to describe it at that very simplest level. If we are looking at the criminal cases, for those of you who are in criminology, we want to look at them and describe at the very basic level. If we are looking at maybe the current affairs, we want to look at it and see this issue of the killings of the young ladies. We want to do it at the very basic level, that we can measure and describe this by use of what we are referring to as central. Central means vital, at the center. So there are basically 3 measures of central tendency. 1, the mean; 2, the mode; and 3, the median. So let us look at each one of them at a time. So first we look at the mean. When we talk of the mean, this is just the average. And how do we get the average? The average is the sum total divided by the number. That's what gives us an average value. That we are looking at it as an average. But the sum total of observations, suppose our observation is X. We are looking at variable X. So the total of variable X divided by how many values of X are there. How many observations are there? The number. So this is what we is commonly referred to as the arithmetic mean. We have also other forms of mean. The geometric mean is also an example, and harmonic mean. So at our level, we'll limit ourselves to the arithmetic mean because this is the most commonly used average. Those of you who are in mathematics, who will apply statistics, have courses in statistical concepts like BCom, you look at this, even those in criminology, you have social statistics, you will analyze those other forms in your respective areas. But for this course, we give you the very basic, and this is the commonly used average, which is the arithmetic mean. So we have looked at grouped and ungrouped data. So if the data is ungrouped, then our arithmetic mean is just simply the sum total divided by the number. For example, if I have the observations 2, 4, 6, 8, and 10. So the mean, which gives me the average value, is the sum. 2 plus 4 plus 6 plus 8 plus 10. That gives us 30. How many observations are there? 1, 2, 3, 4, 5. There are 5. So 30 divided by 5 gives you 6. That is the arithmetic mean, the average. So if this is the number of children in households in a given village, so with an average of 6, then we are giving this as the average number of children per household in Kibabi area, Kibabi ward, Kibabi village, Kibabi students is 6. That's how we interpret. Remember, we say statistics deals with methods of collecting, organizing, analyzing, interpreting, presenting data for purposes of decision making. So we are analyzing, and as we are going to look at this analysis, we'll be providing the interpretation of the analysis, because that is now where the statistics becomes vital. We look at your age, we find out the average age for all of you students. Then we say that on average, most first-year students are of this age. On average, the daily income of this group of people is this much. It gives us an average value. On average, the sales of this enterprise is this much. On average, the working hours of this type of employees is these hours. On average, the cases that are determined by courts in Kenya are this much. See, those are the conclusions that we are drawing, that we can also draw from the various phenomena that we may consider. On average, that the members of the third estate, fourth estate, the journalists, are reporting, say on average, 4 articles accurately. Because we know sometimes you say this, then they say this, because they know how to add flesh where they are supposed to add to make it more juicy. So as you make it juicy, then that becomes better. Daktari nahitaji not staki soup. Nimejaribu course enrollment inakataa. I announced for the last part, Dixon Ongoro. Visit Odell office, I'm there now. It was communicated. They'll help you to enroll. I said enrollment When you want to enroll to KUC 1250, January 2024. That's the course you should enroll in. Then you'll be able to access all the materials. Aki nimeenroll na hii course inakubali, but nikipata ni ya 2023. Nikipitia, we can update. That's not a problem. Inakataa juu hatujamaliza fee. Payment of fees is your own problem. What if I don't have units? I don't know what units you mean. Dorcas, Natam. I don't know the units. So kindly check with ICT or check with Odell. You must have registered. If you don't register, you are not registered student, then you cannot access. Wengine hatujawekewa units kwa portal, check with your COD, hiyo sio yangu. Nani anangojea 1K? Muna ni confused. Hatujapata scholarship, that's not my business. My work is to teach. Nani wenye hatujamaliza fee, sasa enda kwa portal, sina units. Have you registered? Daniel Wekesa. Well, sort out your problems. Ask me things of this course. Bring more involving examples to endelea. Get past papers. There are very many of them. You can come, I give you a whole set from 2003. So we are looking at measures of central tendency. And the mean we are saying is an average value. For group and grouped data, it is just the sum total divided by the number. So if this does not occur with the frequencies, for example, if you have 2 children, 4, 6, 8, 10 in a household, the sum is 30, divided by the number is 5. That gives you an average value of 6 children per household in this consideration. I've given examples of where else we can have that average. Now we proceed. Suppose the observations occur with some frequency. So if some of data occurs with some frequency, then we must get the product. That for this case, like for our case, I don't know what we had gotten that time. I didn't record it. But if it occurs with some frequency, then the following is adopted. For ungrouped, then the mean which we denote for observation X, this is given by if we data occurs with some frequency, then the mean of this data is determined by X for the mean. This is given by sum of the frequencies by the observations divided by the total number of observations. Where this is X is the observation. Please get it correct so that you don't confuse with group data. The F here is the frequency. This is one group, but if it is grouped data, remember we looked at group and ungrouped. So if it is grouped, the mean is obtained by the same formula, sum of fx divided by sum of f, where now this x is the midpoint of the interval. This remains to be the frequency of the interval. And sum of f gives us the total frequency. So we need to differentiate this. For grouped and ungrouped, we are using the same formula, but for ungrouped, the x is the actual observation. For grouped, the x is the midpoint of the interval. That is what we need to know. That we can do it this way. Allow me to look at those other measures so that we do examples for the three. This is for the mean. How about the mode? By definition, the mode is the most occurring value in the data set. The most, that which occurs with the highest frequency. So it's very easy for us to determine if it is ungrouped. For ungrouped, we just look through that which occurs highest number of times, that which occurs with the highest frequency. That gives us the mode. But for grouped, we must determine, because group, it will give you an interval. So we must determine what we refer to as the model class. The model class. So this is the class with the highest frequency. That's the interval, the one that has the highest frequency. But we can go further and now estimate the mode. The mode will therefore be estimated by N plus F1 all over F1 plus F2. What is L? L is the lower class boundary. Remember, I defined what the boundary is, the lower class boundary. F1 is the difference in the frequencies of the model class and the preceding class. F2 is the frequency, the difference in the frequencies of the model class and the post-model. Pre-model means that coming before. Post-model for F2, that which comes after. That is how to determine the mode. Now we need to take note that the mode is very important, because if the frequency, the table distribution has only one, then we refer to that distribution as unimodal distribution. If it has only one mode, there are times you can get two values for the mode. That one is referred to as bimodal distribution. And if it has more than two, then we refer to that as multimodal. This is what we are saying. Unimodal means it has only one mean, bi means two, and multi means more than two. So it's possible that in a given set of distribution, you can have either of these modes, with one mode, with two mode values, and with more than two. When it's one, it's unimodal. When it's two, it's bimodal. When it's three, it's multimodal. That is what it is. And finally, we can also look at the median. Because there are just three. The median. Median is a measure of position. Unlike the average and the mode. The average, the mean, average value. The mode is the most occurring. The median is the middle value. That which takes the central position, the middle position, is called the median. So if it is ungrouped, So the median is just the n plus 1 over 2. The n over 2 item. I divide n plus 2 item. So that when you arrange them in an array from ascending order or descending order, that n over 2 items, where n is the total number of observations. Just arrange them. How many are they? They are 10. 10 over 2, that gives you number 5. So the fifth item gives you the median. But if it's grouped, then we estimate. How do we estimate? The median, which we can note as MD. This is given by N plus N over 2. Am I moving too fast? Am I moving too fast? Okay. Let me go through them from the slides first. Then we can go to the board. Let me take them through the slides. Then we can go there. I've just explained it. Let us go through the slides first. Then we can see to it with example. So we are talking of the mode as the most occurring in a data set. So if it's in a group, we arrange the data in either ascending or descending order of magnitude. Then we apply which one is occurring most. Like if we have 10, 30, 40, 20, 50, 60, 20. So you arrange it as an array. So which one is occurring most? It's only 20 that's occurring twice. Other values are occurring once. So the most occurring is the value 20. So 20 is the mode. Look at the number of vehicles or people killed in a road accident by different vehicles. Lorries have 10, cars are 40, buses 22, matatus 16, others are 12. So which one has killed more? This is car. That is the mode. So I think it's now visible. Okay. So if you look at the number of people killed in road accidents by different vehicles, internet connection is unstable. Then you realize that the cars have killed more people. So the model vehicle that kills most people is the car. So we can look at this and say that cars are causing more accidents in our road, killing more people than any other. That's how the model is. So if it's only one, then we call that unimodal. If there are two, we say bimodal. If there are more than two, then that one is multimodal, the way I had explained. But if it occurs with frequency, then we can estimate. How do you estimate? The mode is estimated by the formula L plus F1 all over F1 plus F2, where F1 is the difference between the frequency of the model class and the pre-model. F2 is the difference between the model class frequency and the post-model. That one, we look at it. Then all this we shall multiply by I, where I is the class size. We will not look at an example for now. We proceed. I want us to understand the concept. Let us understand the concept first. How about the median? The median is only but a measure of position. That which takes the central value in a set of data. So if we arrange the data in either ascending or descending order, that which is at the center. Like look at 8, 4, 10, 2, 6. So we arrange this in order. We have 2, 4, 6, 8, 10. At this, how many are they? 1, 2, 3, 4, 5. 5 plus 1 is 6. Divided by 2 is 3, the third position. Look at the second case. 8, 17, 14, 9, 13, 10, 15, 12. In an array, it's 8, 9, 10, 12, 13, 14, 15, and 17. What happens? Our n is 1, 2, 3, 4, 5, 6, 7, 8. So n plus 1 gives us 9 divided by 2, 4.5. So it is the value. And if you check item 4.5, it lies between 12 and 13. So we average those two. 12 plus 13 divided by 2. But if it is grouped, then we estimate. And we're estimating by a formula that I was explaining. L plus n over 2 minus CF over F times I. Well, L is the lower class boundary. CF is the cumulative frequency preceding that median class. The median class is that which occupies the n over 2 item. Then I is the class size. So I'm looking at these three at a go because I want to look at it. Is that okay? I look at this three because they are both measures of central tendency. So how do we go about it so that we get the best and describe what this is all about? Let me get some examples from here. Like for the case of the data that we had earlier, we had 10, 20, 20, 30, 40, and 60. So we look at that for the mean, mode, and median. That will be for one group. Then for groups, we want to look at this. 1 to 10, 8, 11 to 20, 14, 21 to 30, 12, 31 to 40, 9, then 41 to 57. So we want to look at this set of data. Let us see how we can compute these three measures of central tendency. Umeiosha na hii maji yako. Okay. So we want to look at the ungrouped data, and we have the set of data 10, 20, 20, 30, 40, and then 60. For the mean, this is sum of x divided by sum of f. And this will give you 10 plus 20 plus 20 plus 30 plus 40 plus 60 divided by how many are they? 1, 2, 3, 4, 5, 6. Divided by 6. So this is 50, 80 plus 100. This gives you 180 divided by 6. And that will give you 30. For the mean. So the average value here is 30. Now, how about the mode? The mode is the most occurring. 10 is occurring once, 20 is twice, 31, 41, 61. So the most occurring is 20. The most occurring. That's the average value. And then if it's for the median, the position, we are looking at that which takes the central value. It is n plus 1 over 2 item. This gives you 1, 2, 3, 4, 5, 6. 6 plus 1 over 2, that's 7 over 2, and that is number 3.5. So 3.5, it lies between number 3 and 4. This is 1, 2, 3. This is number 3 and 4. Because I'll have 2, I'll have 2. So the average of the two is 20 plus 30 divided by 2, and that gives you 50 over 2, and that gives you 25. The average of the two middle ones. So this is for a group. So we'll be coming to make comparisons. 30, 20, 25, as we interpret that set of data. Then suppose it was grouped. And we have the following that I said. We have 1 to 10, 8, 11 to 20, 14, 21 to 30, 12, 31 to 40, 9, then 41 to 57. This is the F, and this is our X. Recall what we said. For us to find our mean, this is now group sum of Fx all over sum of F, where this X is the midpoint. So we must get our midpoint here. This was the observation saying this is now max, or whatever it is. So our midpoint, you can treat it now as X. So from number 1 to 10, which is the halfway. So there are 10 items. Divided by 2, that gives you 5. So if our midpoint here is 5, for the second interval, it will give you 15. The third interval, 25. Then 35. Then 45. We have now our frequency and X as given. So we need to get the product Fx. So 8 by 5, that gives you 40. 15 by 14, 20, 60, that's it, 210. Then 12 by 25, that is 300. 35 by 9, This is 45. 27 plus 4. That's 33. Then 7 by 45. That is 35. 28 plus 3. 31. So what do we require? For the mean, it is the sum of this. This and this is 22. 22 plus 12, 34. 34 plus 9, 43. Plus 7 is 50. We also need this total sum of fx. All this is 10. 5, 6, 9, 10. Then 3, 6, 9, 12. And therefore, our mean will be equal to the sum of fx, 1,200, divided by the sum of x, which is 50. And this gives you, this will be this, and this will be 2. Remainder is 2 into 24. That gives us 24 for the mean. The average value is 24. How about 4? The mod. The mod we said is L plus F1 all over F1 plus F2. And this we shall multiply by I. We defined what L is, the lower class boundary. F1, the difference between the frequency of the median class and the pre. F2 is the difference in the frequency between the median class and the post. I is the class I. So what is the model class? That which has the highest frequency. So we look through this. The highest frequency here is 14. And 14 corresponds to 11 to 20. So our model class is 11 to 20 with a frequency of 14. So if we substitute in our formula, then our model class will be equal to, what is the lower class boundary? We look at the boundaries here. The average of 10 and 11. That will give you 10.5. That's our L. Plus F1. F1 is the difference in the frequencies of the model class, 14. Free is that which comes before. So this is 14 minus 8. All over 14 minus 8 plus F2. The difference in the frequencies of the model class and the post, that which comes after. So this 14 minus 12. So this will give you 10.5 plus 14 minus 8 is 4. 14 minus 8 is 6, sorry. 6 divided by 6 plus 2. So this gives you 10.5 plus 6 all over 8. And what is 6 over 8? This would give you 10.5 plus 6 over 8. That's 0 point into 60. That's about 9. 9 is 54. 7 is 54. 56. Or thereabout 0.9. So if you average this, you get 11, about 11.4 approximate value. So this was the mean. This is the 3/4, 75. 275. A quarter is 0.5. 0.25. 3/4. That is 3/4 is 3/4. 75. Please, I want to repeat. Why is it 5 and not? Why 5 and not 5.5? How many units are there from number 1 to 10? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half of 10 is 5. From 11 to 20. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, that gives us 10. So half of that is 5. So between 11 and 20, we have 10 units. Half of them gives us 15. Hope that is now clear. What we need to be careful is in terms of the mode. The mode is important. That we must identify the model class, which is the class with the highest frequency. We look through the frequency. The highest is 14. It corresponds to 11 to 20. So the model class is 11 to 20 with a frequency of 14. So what is the lower class boundary of that model class? We said we average these two. That gives us 10 plus 11 divided by 2. That gives us 10.5. Now, what is F1? The difference in frequencies of the model class and the preceding. So it's 14 minus 8 to give us 6. What is F2? The difference in the frequencies between the model class and the post. Post is what comes after. So this one is 14 minus 12. That gives us 2. So 6 over 6 plus 2, that gives us 6 over 8. Plus 10.5, that's what gives us 11.7. Which one? 11.25. Okay, yeah. 10.5 plus 0.75, that gives us 11.25. Please correct that. Thank you for the correction. So it gives you 11.25. That is the mode, the value of the mode. Then we look at the third. Please note this, that the mean is 24. The mode is 11.25. We want to get the median. How do we find the median? The median is estimated by what we gave as the median is L plus N over 2 minus CF all over F. This multiplied by I, where L is the lower class boundary of the median class. N is the total number of observations. CF is the cumulative frequency after the class preceding the median class. F is the frequency of the median class. I is the class size. I is the class size. So, how do we identify the median class? Our median class is the N plus 2. So what is our N? Our N is 50. So N over 2 gives us 25. So we want to see where this number 25 is. So we do this by generating what we call the cumulative frequency. So how do we generate this? Pay a little attention. that if these are marked, how many students scored below 1? So there is none. How many students scored 10 and below? There are 8. So 10 and below, they are 8. How many students scored 20 and below? So if you look at 20 and below, we have 10 who scored between 1 and 10, 14 who scored between 11 and 12. So we add these two. 8 plus 14 to give you 22. So 22 students scored 20 marks and below. How many scored 30 marks and below? So it will be 8 plus 14 plus 12. That will give you 34. What you are doing, you are accumulating. Accumulating means you are adding as you go by. So this is what gives you the cumulative frequency. So in the next one, it will be 34 plus 9 to give you 43. And finally, those who scored 50 and below is 43 plus 7. That gives you 50. So from this, where is number 25? Up to here, 22. So 25 must fall among these 34. And 34 corresponds to the interval 21 to 30. So our median class is 21 to 30. Our median class is 21 to 30. So if this is the case, therefore, our median can be estimated as N, what's the lower class boundary of this interval? 20 plus 21 divided by 2, that gives you 20.5 plus N over 2. N is 50 over 2 minus CF. We are here. Cumulative frequency up to the class preceding. What is before? That is 22. Divided by F is the frequency of the median class. And the frequency of this class is 12. Here. The class size is 12. So this gives us 20.5 plus. This is 25 minus 22 all over 12 times 10. And this will be equal to 20.5 plus. This is 3 over 12 times 10. And that's a quarter. So this is 20.5 plus 0.25 times 10. And therefore that will give you 20.5 plus 2.5, and that will be equal to 23. That will be equal to 23. So, in the computation of the median, we need to be cautious and identify where does that middle value, central value lie. Once we have identified where it lies, then we identify the median class. With the median class, we can get the lower class boundary, we can get the frequency of that interval, and we can get the cumulative frequency up to the class preceding that, as given under this cumulative frequency. So meaning therefore that if we substituted, then the median will be 23. And if this is the case, then we are saying that they are 50. So student number 25 must have scored a mark of 23. That is the interpretation. Student number 25 scored a mark of 23. And this is what we are saying. We wish to look at another example for group data. Let us check and see for questions that have been raised, and we can solve them or respond to them from example number 2. Let us have this table. Please let us have this table in terms of the height in centimeters and the number of seedlings. Then from this, let us estimate the mean, the mode, and the median. Then we give the answers of the three in the chat box. We have about 8 minutes for that. Let's use 8 minutes for that. Andros, please. Do my something spoil. One of my joke. Should go up to 10:30. But before that, please. On the midpoint. See what the midpoint will give. The one on the midpoint we responded. Wanataka tuajie hapo. Can give them as an assignment. They do it. Enda kwa Wi-Fi. And is answering them. The question is, there is the question, estimate the mean, mode, and median of the data. Please check. Confusion in working on the midpoint. Get the average of the Please read the chat box for adjustments on the midpoint. Read the chat box. Read my comment on the chat box about the midpoint. Most people are asking. Please, nimesikia. Check with your friends. Now, I think we can pick up from there next time. I see most of you are complaining. Doreen Nasimi, this cannot be 9.5. It cannot be 9.5, the first midpoint. It cannot be 9.5. Doreen Nasimi, that's not 9.5. Please, we can pick up from there, but consult with your colleagues. Confusion is there on the finding of the midpoint. I've cleared the confusion. The average of the lower and the upper limits. What are you not seeing, Angela? You read Ruto, your answer is wrong. Check the average of the two. Umbasi is higher, is okay. Doreen, that's fine. Thanks for today. Wamechoka. Okay, there is public outcry that we adjourn from there. No problem. We adjourn from there. So, ladies and gentlemen, let us respect each other's opinion. Veronica Omoyo. Now, with this in mind, then we can conclude. We can conclude our lesson. So we want to conclude. We want to conclude. Will you repeat the same? We can start from there. You do the exercises first. Let's start from there. And on this exercise that I gave you, exercise question 1 and 2, can you also proceed and get the mean, mode, and median? You can do this in consultations. You can do this in groups. I'll pick up by doing the example that I've given you, for example, 2. I'll pick it up next week. But for what we had given as that exercise, do this for your own practice. Consult with your colleagues. Where in doubt, you can consult with me in ABB 214. I'm available in ABB 214. So if there is any question, you can ask. I see there's public outcry that we do a repetition. I'll repeat this next week by doing one example. Please, if there is any confusion, raise it so that we correct it in the next class. We can adjourn from there. The notes I said and I repeat, visit Odell. You are directed by Mr. Okoli on what you are supposed to do to register and access the notes. Okoli, they're asking for enrollment key. It was KUC. Enrollment is KUC 1250 January 20. JAN Jan 2024. All is in caps. Na mwache kusumbua class rep. This thing was on the wall. Yes, you have this. Exactly what Brenda has posted. That is it. So we can adjourn from that. Thank you so much. We can end our lesson at that point. To help us for those, the sake of those who can't. You don't truncate. So we can start our next lesson at 7 next week, so that we repeat what we have given as exercise. Then we start to cover what we are supposed to cover for next week. So please, next week, come early. We'll do those exercises. We'll do those exercises that I've given you. We can have 2 examples, then conclude as we proceed. Thank you so much. We adjourn.